Good morning, everyone, and good evening to those of you who are actually on the on the other side. I'll just wait for all of my speakers to join the stage.
Hello, everyone.
Hi, Alban. Hi, Tuan.
Good to be here.
That's missing Jeff, and we will get started in a sec.
I got a text from him, so he should be around. Hi, Jeff.
Right here. Hi, Jeff.
Hi,
All right. Hi, everyone.
Hi, Tuan. Hi, Alban.
So I am very excited to moderate our next panel. I'm going to jump into the topic right away, and then we'll jump into the question even faster on that. So in the recent months, we've all experienced what supply chain risks means, right? We've had it at a global scale. All of a sudden, I mean, which is really what supply chain risk is. And so relocating production closer to the customer and shortening the supply chain is today becoming already a reality for more and more manufacturers. So what role has additive manufacturing to play, and what should we be thinking about when we're going through the supply chain reinvention phase? So with me today to discuss this topic, we have Alban, the CEO of Prodways, Jeff Mize, the CEO of PostProcess Technologies, and Tranpham, CRO of AREVO. If you could all each of you introduce yourself briefly, that would be great, and then we'll kickstart with the panel questions. So Alban, we'll go with you first, and please let's keep it under 1 minute as much as we can. I know you all have very big background, heavy on additive manufacturing, but let's try to keep it short so then we can jump again into the questions.
Thank you, Nora, and hi, everyone. So yes, I'm Alban. I'm the CEO of Prodways and Solidscape. I've been with the company for 5 years, and I have a long background of high-tech industries. And here we develop wax printer for jewelry, resin printer, and plastic laser sintering printers under the Solidscape and Prodways brand.
Thank you. Jeff, you want to go next?
Sure. So we have a lunch bet. Whoever gives the shortest, most impactful introduction, whoever gets the longest has to pay for lunch. So I'm going to be well over what Alban said there.
I should have reminded everyone of that at first. Yeah, you're totally right.
Yeah. So I'm Jeff Mize, CEO of PostProcess, based in Buffalo, New York, where it's going to be 75 degrees Fahrenheit and sunny tomorrow. One of the best kept secrets in the country here in the U.S. Joined Daniel Hutchinson, our founder, back in 2016. And Daniel had a really unique vision to automate the third step in the additive process. My last 2 companies were taking analog processes, agriculture and mapping, and digitizing them. And so I thought it was pretty cool that to get into production and reimagine the supply chain, which we'll be talking about today, you really need to have connectivity. So I joined in 2016 as the 4th employee of the company, which was a very early start. But now we're shipping product to 14 countries on 4 continents, and the need to automate that final step and connect that digital thread has really become essential. So excited to be here with Alban and Tuan and Nora and talk through what's happening, especially with the impact of the pandemic and being at that inflection point where we really see production starting to take off.
Thank you, Jeff. Tuan, you're next.
Hi, I am Tuan Tranpham. I love 3D printing. This is my accidental passion. It's really not a job. And I dedicated 17 years in 3D printing, spent the first 10 in polymer, spent the next 6 years with ArtCam and desktop metal for metals. And I'm very happy to join AREVO 6 months ago, raising 26.2 million and do a Kickstarter Indiegogo campaign. And with continuous carbon fiber, we are trying to disrupt the urban e-mobility and having fun at the same time. And we just double our staff size in recent times. So this is an exciting time to regroup and come out of this pandemic stronger. I'm pleased to be here.
Absolutely, and thank you. Thank you all for the introductions. All right, I'm going to jump into my questions. So as a reminder, our topic today is reimagining industrial supply chains using additive manufacturing. So my first question to you is, what is your read on that? Are we actually creating new industrial supply chains? Are we reimagining existing ones? And so I'm going to pick Jeff to start with.
Sure. Yeah. No. Thanks, Nora. I think the answer is both. There's examples where we're reimagining, Supply chains, to me, one of the great examples is dental and mass customization, which is very difficult to do with traditional manufacturing technologies. But also, I think that some of the existing supply chains are being reimagined. For example, virtual warehouses, and the need to no longer stockpile spare parts in a central warehouse, but being able to have a digital file that can be sent to a printer anywhere in the world is definitely something where we're seeing a whole new supply chain emerging as a result of the digitization of manufacturing.
Yeah, I couldn't agree more. And actually, Alban, I know you and I had discussion about mass customization of well, medical devices and healthcare as a more global industry part. Do you want to touch base on this?
Yes, I think indeed some industry have only been able to emerge thanks to 3D printing. If you take the hearing aids industry, everything is now 3D printed, and this has dramatically changed the way we address these solutions. And that was only possible with digital and 3D printing because every part is unique. You mentioned the dental business, the aligner business is about manufacturing hundreds of thousands of unique parts per day. And the challenge was not about the 3D printing, it was about the ERP, the file management, tracking, how do you make sure that everything flows when instead of doing 100,000 unique same parts, you know, each of them are different. And what is sure that we've learned from this early market. This market had no choice but to scale up 3D printing. They've done a great job. And now we know how to scale up 3D printing for other industry. And we see that all these other industry are realizing that once they have the right material, the right finish, the right product from 3D printing, they certainly benefit from all this digital evolution that has been brought on. And that's very exciting, yes.
Yeah, absolutely.
So my take on this is we've been pitching additive manufacturing for quite a while now, and it's really about the value of going digitally and produce it locally, but also on demand. So I think this is more than just a supply chain. With the supply chain being disrupted because of pandemic, you want to 3D print as much as possible. You want to merge the part. You want to simplify the parts. But the dirty secret is that all 3D printing technology needs a post-processing. And so it's not like just 3D printing, just moving manufacturing back to America, to the Western world. You also need to factor in automation for post-processing. So this is beyond just supply chain question. It's also a business model. Do you really need to own it, or do you subscribe to it, or do you just want to buy it on demand? So this is a good time to rethink about how to approach 3D printing, additive manufacturing, but thinking of your business impact more than just supply chain.
Absolutely, and actually that's a great transition to my next question that's going to be a little bit more oriented towards you, Jeff, about actually post-processes and finishes. Oftentimes, like this question of post-processing is left out when we're talking about supply chain. So I'm really glad you're here because this is actually a very crucial element, especially for the end users. At the end of the day, we're getting parts in our hands, and so we need those to be really good and perfect, and a lot has to do with finishes and post processes as well. And so my question to you is, what steps is post-process technology specifically taking, but then the industry as a whole, in facilitating the adoption of AM for production parts in regards to post-processing?
Yeah, sure. So when I first joined almost 5 years ago now, I would often hear post-processing, the dirty little secret of the industry. And at my first trade show, I thought, wow, like what has Daniel, our founder, done that they're calling our company a dirty little secret? But then realized the creativeness and innovativeness of Daniel. He named the company after the function. And he was very proud that he paid $3 on GoDaddy to get postprocess.com. But yeah, as I looked at things early on, and I've been in the industry only 5 years versus Tuan and Alban, who've been in the industry much longer, but I didn't fully understand how critical support removal, surface finish, and now some other functions were. And back 5, 10, 15, 30 years ago, 3D printing was used in lower volumes, often in the R&D lab. The parts didn't see the light of day. And so using manual labor, using traditional technologies was okay. But now, as we see prototype volumes really increasing dramatically, and those prototypes being used for much more than form, fit, and function in the development engineering lab, the need to have parts that are consistent is absolutely critical. And as we continue to see more and more industries seriously consider production with additive parts, having that digital thread connected is absolutely essential. So if there was one thing I would highlight that is the core of what we're focused on here at PostProcess, it's the software component, the machine learning, the data science element to connect design to print to post-print and offer the benefits of traceability and a number of the other things that come along with that digital thread. So that's absolutely critical. And then here at PostProcess, we have a full stack of software, hardware, and chemistry. Getting that all to work together, leveraging, again, our software platform to ensure consistency, whether you're doing one part or 10,000 parts, is absolutely essential. And so it's exciting to see the number of software developments that are happening, the vast majority with an open API architecture, so it makes it easy to connect. And some of the new printer developments are pretty exciting. Things like Evolve with their STEP technology that can produce millions of parts per year. And of course, folks like Carbon, I think, have some new technologies that will allow us to make additive for production a reality and allow more reimagination of the supply chain.
Yeah, I agree, and I will go back on the software side in a second. But before that, I would like to continue this discussion really on materials as well. And so I have a similar question for you, Alban and Tuan, that I had for Jeff, but more like twisted on the material side. What can be done today to accelerate production grade material development? And Alban, we'll go with you first on this one.
Thank you. Yes, I think 3D printing is about making the right part, and I agree with the comment from Jeff about the post-processing and making a finished part. When you think there are many other manufacturing approaches that need post-processing. When you inject, you also need to remove some marks. When you machine, you need to finish the product. So it's the global picture, and yes, having the right material with the right mechanical properties is important. I mean, if you want to make a shoe sole, you need a flexible material. If you want to make a finished part in a car, you need it to be resistant to some mechanical properties. And if you want to go in the aero, you need fire retardant. And there has been a dramatic change in the industry in the last 2-3 years. I was impressed when we were doing real trade shows a couple of months ago. I noticed that in trade show, you were now seeing all the chemical companies having their own booth on trade show. This is really opening up. This is exciting. We're able now we're launching almost 2 materials every year on our machine portfolio. People want to use the material that they know, that they've qualified in the past. So PA6 is known to the automotive industry. They don't know what is PA12. So I can spend 10 years convincing them that they should go with PA12. But when I offer PA6, I save this 12 year, and that's important. So I think it's true. We need to continue to grow the materials. This is a trend, and this is very positive to manufacture more parts. I totally agree, yes.
We started with the focus of aerospace. So we thought that when you talk about material, it's really what the customer is looking for is high material quality and repeatability of product. And basically, can you have repeatability of the product? So we started immediately for mid to large size continuous carbon fiber because we deemed that the chalk fiber was not strong enough. So if you have a strong enough material, so we went all the way with continuous carbon fiber with PEAK, but it's very clear that you need material versatility. You can have more material, so we went with nylon, but what customers really want to go production is it needed to be cheaper, faster, but the quality cannot be compromised. So everybody's trying to enable more material, but higher productivity. So I think material quality cannot be compromised if you want to do production.
Totally agree.
I just jump in. Building on Alban's comments, I mean, it's incredible. There's a new material. I'm not sure it's every day, but there's at least a couple new materials each week, both on the polymer side. I'm sure everyone's seen some of the recent announcements from Loctite Henkel Ken Kisner and his team continue to produce just an incredible number of resins that are out in the market. And then also on the metal side, and the number of different composites that can now be 3D printed. So here at PostProcess, our chemistry team is working nonstop to make sure that we can effectively post-print those. But I think the variety of materials will continue to allow us to expand and grow. And I think Alban mentioned it as well about the number of material companies now attending the trade shows, coming to AMUG and Rapid and Formnext, and some of the moves you see in the market like Covestro buying part of DSM. So I think the major chemical companies see the opportunity. And I really believe we're at that inflection point where we're going to see additive continue in the lab. And we have some customers that are prototyping hundreds of thousands of parts per year, but from automotive to aerospace to medical, we're seeing true production applications that aren't going to replace injection molding, but for critical components in the hundreds of thousands or even the millions per year, I think the materials, the printers, and now this end-to-end connected digital thread will allow us to make manufacturing reality. And again, the topic of this discussion, continue to reimagine supply chains in ways that weren't possible with how manufacturing has been done for the past 100 plus years.
And actually, that's a very good point, Jeff. Thank you for the emphasis on this. And on a personal note, like for me, like I'm selling additive manufacturing. I've been doing this for over 10 years now, and I have to say it's sometimes it's a bit hard to keep track of all the new material developments. So I'm definitely thankful for quite a few of the databases that are there. I won't drop name any here, but I'm really thankful for those databases. And but that being said, like again, I want to take a little tangent here, but do you see, like, as we're developing all of those new materials, that there will be a world where additive manufacturing will probably replace injection or CNC maybe in some cases? Like, do you already see that happening? Yeah, go ahead, Tuan.
I had two comments. And the first comment is actually beyond material. There are two things, right? Actually, what's more important than material is actually what is the customer looking for in material property. That is much more important than what material, because what material has often been confined by what was able or available conventionally, but not necessarily in additive. So two-part. If you look at the material property that is your product and then go to the geometry, you can use a different material or the same material, but use lattice structure and change the material property in the same material or different material. So the hardware using software can actually take things to the next level. But at the same time, you're not only confined what was available, now you're also seeing a direction of 3D printing, doing in situ developed material in process, where you're blending on the fly. It wasn't pre-made or pre-preg. It was made on the fly to get what you want. And I want to slip in here also as well. Another part that I'm seeing in the industry is the hardware. Why have nobody, until Inkjet came about, why do 3D printers not have eyes and brains? What do I mean by that? Why do they not have machine learning and vision and capturing all this data that you will need for certification documentation, that every layer you know the material property, and therefore you can compensate on the fly? I think hardware manufacturing, the whole industry needs to wake up and leverage the other component of the fourth industrial revolution, because 3D printing is not isolated.
Thank you. No, that's a really good point. Thank you, Tuan. I'm going to start looking a little bit into the questions from the audience, because I do have quite a few more on my own, but I want to share the privilege with the audience. And actually, the first question here that has been voted, and by the way, this is a reminder for the audience, please put your questions into the Q&A panel, and you can upvote questions from that are already there that you think should absolutely be asked. And so, okay, the first one here that's been voted, I think you all started to answer it a little bit, but let's have like a minute to really answer that. Like, what do you think will be the main impact of additive manufacturing in the near future? I think this is a really open question. So who wants to go first? And I would say, like, if we can, I would like to tie it with one of my questions I had about case studies of how, like, if you've seen, you probably have through your customers, for example, some case studies of integration of additive manufacturing in the supply chain. I would like, as much as we can, try to combine both.
I can take that. So we try to inspire the world that continuous carbon fiber can do an e-bike. And what we experienced with the pandemic is that a lot of components, a lot of the parts could not be done because traditionally, carbon fiber bike, you had like manual labor, 2 weeks, 300 patches, and that got disrupted with the 6 feet distancing and components being sold out and the demand for e-bikes going. So we were looking at, can we move that to additive? We want to use that as a technology demonstrator, marketing demonstrator. Can we do an e-bike all in continuous carbon fiber? And then because of the pandemic, we couldn't get a lot of the components. We look at the bike, okay, what else can we start doing? The seat tube, we starting doing the fork, we starting to do the wheel set. So we become creative when supply chain constrained, you can't get the components or you can't get the pieces or you have to wait it from Asia. So you become creative and moving to additive as much as possible. But at the same time, instead of doing additive, it enables you to do a design and then try to fit components to fit your design. We can at the same time look at the components first, what we want, and merge a lot of the design. So really take advantage of additive for supply chain. It's simplifying the design, simplifying supply chain, and move it in-house. But another point is also, in my 17 years in 3D printing, the business model is also growing from a supply chain point of view. Very close, like a car. In the beginning, you bought a car, you own it. Then you want a new car every 3 years, so you lease it. And now today, you don't even need to own a car. You just go jump into Uber. You just want to get from point A to point B. What I've learned, especially in metals the last 6 years, is I learned that customers really don't care how I do this metal part. They care about the material property, but they want it cheaper, faster. And if you can do it better, it's awesome. But they really don't need to own the equipment. So I see a transition where very soon, customer with the supply chain, they do want it locally, but they want it on demand, and they only want it when they need it. So that if they don't, not stuck with equipment and staffing a facility, I think being the Uber selling capacity is where customers just want to buy it when they need it, and additive can do that.
Thank you, Tuan. Yep. So really all good points, and I really love this example. I wish, like, if someone could drop maybe like in the chat a link to the picture of the bike, that would be fantastic, because I think it's definitely worth seeing. Jeff, Alban, any of you want to take it next one here?
Yes, no, I think, I mean, for us being part of the 3D printing community, changing the supply chain is already a reality. It has been a reality for many, many times. You know, some industry are only relying on 3D printing. We serve the jewelry industry. I don't think that anyone else is anymore doing jewelry without 3D printing the parts. I mean, the old time where you were carving and sculpting wax does not exist anymore. The productivity is here. When you look at dental, I mean, this kind of dental arches, you can print them in less than a minute today using printers. So everything is here to make the industry. Some industry need to capture the need for 3D printing. And my message here is more about the volume that we produce. I mean, we can make a lot of volume, but if all the parts are the same, well, it's true. I mean, the day we're going to manufacture a glass in plastic for IKEA in 3D printing is not there yet. But you can see it. You know, everybody wants more customization, and I go again to with jewelry. The time has gone where people would like to purchase the exact same ring, and now you see custom design because the CAD solution is here. You can share file, you can preview it, you can update it. So the customization is coming, and I think that's also driving the need for 3D printing. And that's really a way where it's going to emerge an industry that we're not considering 3D printing. also because they have a request for all this flexibility in manufacturing that it's offering. And then we'll get the rest. We get the local manufacturing, spare parts. We had an experience where we deployed for military operation a 3D printer. It's in a container. It contains everything. It allows you to replace a list of approved parts on site in the same day. And this could serve many other industries. Look, there is a 3D printer in the International Space Station. I mean, that's an example of a agreed local supply chain example, but it's symbolic, but it represents a lot of actual cases.
Yeah.
Yeah, and I just want to comment about sustainability. I think there's a very important element with additive related to sustainability, a lot of benefits, lighter parts, producing locally, but also there's some waste that's created in the additive process. So continuing to work together as an industry to make sure that we minimize that waste, that we can compete against the amount of waste generated in injection molding and take advantage of all the benefits like the locally produced parts is essential. And also something for us here at PostProcess is making sure that every time we're thinking about when a new material comes out, how we're going to clean that new material, the sustainability aspect and the environmental impact is an important consideration. And that's going to, I believe, continue to become more and more important in all parts of the world for us.
And actually, so I have a question that's actually will be more for Jeff and Tuan, because I think Alban, you already gave some answers to it. It's a good question from Gabe here. So what are core industries that are able to take advantage of the digital warehouse that are not currently? So I would like to start with you, Tuan, on this one. And actually, it's specific on digital warehouse, so Alban will still give you a chance to answer it.
Well, yeah, this is still the early days. So there are a lot of, every 2 years, there's a new generation of hardware for most manufacturers. So to answer your question, who were ahead, which vertical? Aerospace, medical, automotive, tooling is doing that. But we're starting to see now, if you could see HP or Carbon and AREVO, we're trying to move into the consumer space, where consumer goods, which is much higher volume, still the quality needs to be good, because otherwise you're going to get liability issues, right? So I think it is slowly expanding as machining gets faster and material gets better and the process is more understood. This is just the beginning where we will see many more verticals moving into virtual warehousing, because it's kind of a no-brainer. Why do you have a physical warehousing with guard, security, electricity, and all that? When you move it to digitally with the virtual warehousing, and every 2 years there's a better machine and it gets cheaper, faster, materials get better and cheaper and faster. For the next 20 years of supply chain or maintenance, you're all set. You're going to leverage on better available material and machines. So it's almost a no-brainer. So if you're not in 3D printing yet, you're going to be a dinosaur.
That's a fact, I think, indeed.
Just to build on what Tuan's saying, I would have, if you'd asked me a year ago, I would have said probably aerospace, automotive, medical. One of those three markets would be the leading market from that perspective. What we're seeing, at least what I'm seeing when I'm out talking with customers, and in fact, we've been out the last 3 weeks visiting customers, which has really been fun. But consumer goods, there are a number of activities in all parts of the world, particularly Europe and North America, where we're seeing consumer goods companies really embracing additive. The virtual warehousing aspect is one component, but for us right now, looking at who's leading from a production perspective, if you would have said the consumer goods industry would be the place that could become the first industry to be producing millions of parts per year on a 3D printer, I'd have said, nah, it's gonna be automotive, potentially medical, or probably aerospace. But right now, I'm surprised, and Tuan, you mentioned it as well, that there's a ton of activity in the consumer goods space.
Well, we're actually going to do it and show it. So just for fun, we did the Indiegogo, and now we sold 4,000 e-bike. Now we have to make it. So we need to build a print farm to make it happen. With 70 aqua machine in Vietnam and of all the countries with tariff and COVID and all that, we can build 30,000 bike frame a year very easily, just using a few dozen machines. And we intend to have 300 eventually. So we're going to make, just like what Carbon have done with Vardell helmet or the shoes from Adidas, we're going to disrupt the urban e-mobility. That's why you're going to see AREVO making a difference. And it's going to make people healthier and safer who want to jump on a bus or subway, commute that way when you can be healthy and do it on an e-bike or e-scooter or e-moped. So consumer goods is definitely exploding.
Alban, do you see the same trend?
Yes, absolutely. I think the only limitation that we have had in the past to apply 3D printing for consumer goods was the price point of the finished parts, because it was really a big gap with what people were used to. And there are plenty of area in the consumer good where there is room for a small premium, and because that's where we are today. There is still a small premium to 3D print consumer goods, but we have a compatible price for mass manufacturing, and we're seeing it. We have plenty of customers that are using 3D printed parts and then sell them to the public. There is always a post-process step, a finishing step, but that's a reality, and this is growing. And again, it's driven by maybe also the fashion aspect of the creativity that is enabled with 3D printing. If you can make more shape, if you can have shorter product cycles, you can revise your product, make a different flavor 6 months after. All this is energizing the consumer goods. So this is absolutely a reality. And I agree with the summary from Jeff. Everything was driven originally by AREVO and medical. Automotive was not ready because of price, and we're seeing automotive now fully embrace. I mean, the shift happened about 24 months ago. It takes a time to qualify and go, but I think that almost every brand today have 3D printed parts in their car. That's a reality. And we're shifting now in consumer goods heavily. Think about sporting goods. That's an area where we've seen a lot of success with 3D printing, because customization is an easy reach for sporting goods. And yes, this is absolutely a reality today. And I know being a dino in the 3D printing industry is a compliment, but it's true that you need to learn about 3D printing, because once you've adopted it, there is no way backward, for sure, for all these companies.
Oh, go ahead, Tuan.
If it just kind of, yeah, so I think laser powder bed was just too slow. Very good material, probably just too slow for automotive, but I think metal binder jetting is going to make a big difference in terms of really high throughput. So automotive is growing and it's self-regulated, so that's a no-brainer. But here's a fun vertical that I'm watching: construction, AEC, construction. It's exciting. We're going to live in a world, in a house where there are no edges, and it's going to be beautiful. Talk about virtual warehousing, all that. Forget about spare parts. You just print it locally with this cement or with the composite as reinforcement, not using metal. So watch out for the emerging new vertical of construction. I'm excited about it. I want to live in a 3D printed house.
And so with that, I think those are really interesting insights. First, thank you for that. And it's going to be interesting indeed to see the industry shifting back into B2C somehow, because, well, we've been there, moved away, and now more or less coming back to it. And so I see like two scenarios, like one that is clearly B2B2C, so really working with the manufacturers of consumer goods directly, and then the direct to consumer, what you were talking about, Tuan, with having Kickstarter's campaign and handling all of the manufacturing and then shipping to the customers directly. So in this second scenario, though, I mean, and again, like there will be a combination of both depending on the product and how complex the products are. But isn't there a risk to scare off manufacturers here and saying, like, you know, we can cut the chase and go straight to B2C without anyone else? So how do we still ensure that manufacturers want to work with us and implement additive into the supply chain, but we're not telling them, yeah, we're gonna replace everything? How do we walk that line? Tuan, you want to go first on this one?
You have to lead by example. You have to show them, and you have to do it. And I think it's also refreshing, right? If for most manufacturers, they make a printer and they're like, you figured out what to print with it. Oh, you can do that. I think most manufacturers should learn what can you actually do with your machine, and be brave and do things that you would never do before. Because if you cannot prove the concept all the way, so many e-bike companies were reluctant. and we cannot wait for them. So we just jumped in and we found out all the pain point that the customer would have gone through using our equipment, relearning that so that we can enable the transition to additive faster by doing our homework, by leading by example. You've got to make it real. And there are a lot of resistance to change. And that's because people are worried about their job. So we need to lead by example and inspire them. It's my answer.
Okay, fair enough. Thank you. Jeff, you are muted. I love the internet, but you're still muted. I'm not sure if I have a way to unmute you distant. No, you're still muted. In the meantime, Alban, do you want to take over on this one?
I'll give you a couple of minutes to solve the beautiful IT mess. No, I think we definitely can capture all these new applications. I mean, I also see that there is a question about do we engage with supply chain and decision maker. This is also a shift that what we've seen. We talk today on a daily basis with people that are purchasing, preparing for the next phase, and it changed also the way we approach this because you need to pre-qualify. You cannot start the project and later on fix the issue and discover that you have some problems. But we are definitely able to capture all these new projects. And again, everything is not made for 3D, and this is not anymore a topic. You know, the question which was
this is fantastic, Jeff. You are doubled. I think you wanted more stage time while you have it.
It's not one of me isn't enough. Sorry, can you guys hear me?
Digital twin.
That was the point I was going to make, Tuan. Somehow Tuan turned my microphone off. Alban, sorry to interrupt. Continue on.
No, but no, sorry. Just to finish, I think will we replace injection? It's not the topic. Injection will exist. Thermoforming exists. That's one more manufacturing cycle. The impact it has brought to the speed of design cycles, the flexibility, is now there, and as the team that create the product are using it, they will use it more. Can we push that to the consumer? I'm not sure. I could totally picture that in the same way you go to pick up something or you know, on a local shop. What you would do is go online. You've broken the, I don't know, the handle on your bike, and you go on the store. You place an order to have it replaced. Instead of receiving an injection molded part, it's going to be printed down in the street on the shop, and you can go tomorrow morning to pick it up. I think that's where we're seeing some trend. I'm not sure that we'll get a direct file to consumer with home printing. The number of material and technology that you need to own to be able to do everything is too large. But definitely, well, again, in the sporting goods industry, you see all these shops need to do a lot of repair. They need to replace parts. In the same way you go there to have your bike reworked, you could go there and pick up a 3D printed parts. So this kind of business model will definitely emerge, yes.
Yeah.
Thank you.
Nora, can you hear me?
Yeah. Yeah.
Okay. I don't know what's going on.
And it's only one of you, so that's perfect too.
Yeah. Some people wish for none sometimes. But yeah, just to go on Tuan's point before he muted me, I think the ROI is an important element, and making sure that we can show that doesn't have to be the same price, I think was one of the points Alban made, but demonstrating that there is an ROI across the entire chain. And the other thing we're seeing, where the customers we're working with where we have the most success, is when there's executive sponsorship. And Tuan, you touched on this as well. There's risk to trying something new. And so it's oftentimes easier to stay with the old way of doing things. What we're seeing, and I think the pandemic's accelerated the fact that 3D printing and some of the weaknesses in some of the global supply chains have gotten the attention of the C-suite. And so that will help from a supply chain perspective, but also help raise the visibility of the benefits of additive manufacturing and allow the middle managers that may be saying, I don't know, I'm not sure it's a good move for me from a career perspective to take that leap of faith. There's clearly some early adopters out there that have been driving the industry many other Dyno Award winners, but to really have this go from the early adopters that are willing to take that risk and are working in an environment that allows them to the early majority, crossing that proverbial technology adoption lifecycle chasm. Getting executive sponsorship is critical. And again, additives touching every imaginable market, as everyone on this call knows, but we're seeing greater sponsorship in the consumer goods area, which I think is one of the accelerants of why additive is moving quicker there than we anticipated here at PostProcess.
And that's a very good point. And I'm seeing the time, and I think we only have time for one last question. I guess time flies when you're having fun. And I absolutely want to finish on something that is really important for me, which is sustainability. And so I think we have a unique opportunity here as we are implementing additive into existing supply chain. I'm going to take this example to actually make it as best as possible in terms of being environmental friendly, more environmental friendly compared to as it is today. And so my question is like, how do we ensure that? How do we make it the best production system possible while being environmental friendly as possible? And I think I want to start with you, Jeff, on this one.
Sure. Yeah, and I touched a little bit on this earlier, but I think two things. One is first making sure that you have metrics in place, and how you define sustainability overall is critical. And then the other critical element, and again, we spend a lot of our time thinking about the post-print step, but it's essential to think about the end-to-end process. And so is there a way, for example, to change the design without changing the form, fit, or function, but optimize the design, in our case for post-printing, so that you think about sustainability and think about how can you use less chemistry to finish your part? How can you have less waste as a result of the post-processing step? So that's where, as I mentioned early on, the software component and that connectivity of that digital thread across the board will be the thing that will allow us to not only meet but exceed sustainability metrics that you see in traditional manufacturing today.
Perfect. Thank you, Jeff. Tuan, Alban, who wanna go next on this one?
I think I have two. I think that there's two important points in this. I would say being able to replace and maintaining sustainability. First, for me, by definition, 3D printing is much better positioned to address the waste issue and management, because you're producing on demand, and keep in mind that it's additive manufacturing, so you only use the material that you need. We're discussing very often with our customer about hollowing out the parts, so removing the interior and creating a skin. And should we do 4 millimeters, 3 millimeter skin? Well, you want to try 4, 3, and 2 at the same time for me, and you'll get the result immediately. So we are, by definition, using much less material as a production methodology. And the question now is how to make that also sustainable in the sense that it can, in the long term, replace what we have. And for that, I think we need to deliver to the promise of 3D printing for these people that implement it as a supply chain source and manufacturing solution. And this ties in with the reason, we need the post-process, we need the Industry 4.0 digital aspect, we need to be able to identify parts, we have an ERP. Think today, when we have printers that make 5,000 parts per day. You have a list of 5 to be printed, they all have an ID. We print a QR code on the part that is able to be read, letter read, with the right character recognition system to then transfer that ID to the final product. All this is automated and is part of our software. We are connected upward with ERP. You start to see some good company also in the AM industry that provide all this file management flow. This is extremely important. And so it's our responsibility, all of us, to make sure that when we get this early adopter or even this C-level manager that makes the decision to adopt 3D printing, we do not fail. And I think that we now have, we can see that all the skill sets and technology needed to not fail is present in the industry. The machines are not anymore developed in the past, the 3D printer were prototyping. So if you fail, who cares? You'll print again tomorrow. Not anymore. If you fail, you lost money, you lost time, the production stops. It's a nightmare. And with the right step, with the right monitoring, we are now able to get this manufacturing going. And that's the main evolution that we've seen recently.
Thank you,
Can
Alban.
I just share 2 observations I've made over the last decade? Because 3D printing for most of us is a passion, not a job. What we can learn from the last recession a decade ago with the emergence of MakerBot, Formlabs, and Ultimaker, there's a lot of changing, regrouping of talent in this recession here. And that's also an opportunity for a lot of customer who's looking to supply chain and additive to recruit and hire talent. So talent is now available to them. And at the same time, that also means these smart brains that is now moving around or available, we could expect more innovations coming about. So we saw a huge boost after last recession, why 3D Systems spent millions of dollars buying 40 companies. I think there is excitement again with the second wind of this new wave of innovations coming in to 3D printing in the next few years. And I'm excited about most technology. It takes about 50 years to mature, from the plane to the car to the internet. 3D printing is about 35 years old, depending on who you ask. So I'm excited about it. Get going, get into additive. Look at your AM strategy, look at supply chain, because this industry will peak in about 15 years. By the time I retire in 2035, that will be beginning of the peak. So people should get started. There's talent to be hired.
Well, thank you. And actually, unfortunately, this is the end of our panel. I would like to remind everyone that I think you will stay within the conference a little bit longer. So people to chase you for the questions, because we have quite a few more here. But Jeff, Tuan, Alban, thank you so much. This was really insightful. And I had fun doing this with you guys. So thank you.